Within thermochemistry, we have this law known as Hess's law. And Hess's law tells us that the overall delta H, or the overall enthalpy of a reaction, is equal to the sum of all the individual delta H values for that given reaction. And this statement can be rewritten as an equation noted as delta H net, so the overall delta H is equal to the sum of all the delta H individual reactions. Now, if we take a look at this example over here, we can see that we have these two elementary steps which help us achieve this overall reaction. Essentially, this hypothetical reaction over here cannot occur in one single step. It occurs in two steps. And if we are given the delta H values for our elementary reactions, we can simply take the sum of these delta H reaction values to get the overall delta H of the overall equation. Now here it can be noted that this first elementary reaction has a delta H of negative 200, and the second one is negative 100. And if we just take the sum of these two values, we get negative 300. So the overall delta H, or the overall enthalpy of this overall reaction, is negative 300. Now, there's two rules that we have to keep in mind of when using Hess's law. And that is, if the reaction is reversed, then we must reverse delta H. So that means that if I were to look at this reaction in the reverse direction, the enthalpy would no longer be negative 300, but instead it would be positive 300. And if I was to flip this reaction or this reaction in the opposite direction, these negative values would also become positive. Now, the second rule we have to keep in mind of is that if a reaction is multiplied by a coefficient, then the delta H must also be multiplied by that coefficient. So if I was to take this overall reaction right over here and multiply it by 2, then this enthalpy value must also be multiplied by 2. So if I multiplied this equation by 2, I would get a 2 here, a 2, a 2, a 2. So the molar ratios all doubled. If I multiply my equation by a coefficient, I must multiply my enthalpy value by that coefficient as well. In this case, I was multiplying by 2, so I would have negative 600 kilojoules as my new enthalpy. So overall, Hess's law tells us that we can determine the overall delta H of a reaction by taking the sum of all the individual reactions, and that if we reverse a reaction, we must reverse the delta H. So if delta H is negative, it'll become positive. If delta H is positive, it'll become negative. And if a reaction is multiplied by a coefficient, then delta H must be multiplied by that coefficient as well.